Hello ladies, in this video we're going to go through the difficult questions in 5F. So 5F is looking at the surface area of a cylinder. So when you think about a cylinder, there's many things all around us that are cylinders. You can think of a Pringle container, a tennis ball container, a glass, circular glass, a pipe, they're all cylinders. With cylinders, it's important when you're doing surface area to always consider the ends. So sometimes you'll come across questions where the ends are included. Sometimes they might just have the base included or both ends included. So just make sure you read the question carefully. Now, because of this diagram here, I couldn't separate the questions, so I'm going to leave it here. I've actually got the textbook open next to me, so I'm hoping that means I don't have to keep scrolling up and down. All right, so 3 questions that I'm going to do. There are obviously harder ones, I think, in this topic, but because we're getting to the end, I just thought I'll do these 3 because they're nice application style questions. All right, question 7. A water trough is in the shape of a half cylinder. Its semicircular ends have a diameter of 40 centimetres and the trough length is 1 metre. Find the outside surface area in centimetres squared of the curved surface plus the 2 semicircular ends. Correct 2 decimal places. Now, think about what usually horses drink out of, out in the paddock, those sorts of things. So, sorts of troughs. All right, so I'm going to scroll. Now, questions where they don't give you the diagram are always a pain in the butt because you then have to draw it yourself. So we've got 2 semicircular ends. So the best way to do that is to just draw your semicircles just like that. And they're the same size, or one should be slightly smaller because it is in the background. And just connect your corners. And this isn't an art class, so it doesn't matter if it's not perfect, but that's what it looks like. Now, it did say that the radius, I think, I'll just double check. No, it's the diameter is 40. So that means your radius is going to be 20. Okay, I'm going to work with radius because usually most formulas have the radius in there. And the length of it is 1 metre. So we've got to make sure that we're working in the same units. So if I wrote 1 and I worked with 1, it's going to, my formula is not going to work because it's going to count that as 1 centimetre, not 1 metre. So we're just going to convert that into centimetres. So 1 metre is 100 centimetres. And there we go. All right, so we've got our 2 ends, and you'll notice that your 2 ends make a full circle. Okay, so we're going to have our whole circle, and that is a radius of 20. So the area of that is, just gone blank, pi r squared, and then just substitute in the 20. So pi times 20 squared. I'm not going to do that just yet. I'm going to do that at the end. So we've done the ends, and then we need to do the half cylinder. So it's going to look something like that. Okay, so I've already done the ends. Now we're just doing the other part. So the area of a cylinder, and I'm just going to make sure I'm writing exactly the same as what you've got in your textbook. Sorry. Not that there's more than one formula, but there's just different ways of writing it. Okay, just give me a second. Two pi r squared h. Okay, so some formulas will have just the 2 pi r squared, which is just the area around the outside. Sometimes I'll add the 2 pi r squared for the ends. So just keep that in mind, that the formula just for the outside area, and I forgot the h, oops, and it's not pi r squared. Sorry about that. Okay, 2 pi RH. Okay, so let's just substitute in those values. So the radius is 20 and your height, which we refer to the length there, is 100. So I'm going to do times 100. So the total surface area, and we only want half of that, okay, because that's for the whole cylinder and we've only got half a cylinder. So I should have written on there that we're dividing that by 2. So your total surface area, we're going to add everything together. So we're going to have pi times 20 squared. Now you don't have to simplify that. I mean, you could write 400 pi if you like, but there's nothing wrong with just leaving it like that and then just putting everything in your calculator. The same with the next one. Obviously that 2 cancels things out, but I'm just going to leave it like this. Okay, because you can just then plug all that into your calculator, but you do need to know how to simplify. So 200 squared is 400 pi. Oops, that should have been a plus. I'll just scribble over it. You do need to know how to simplify that, but if not, if you got just that part there and put in your calculator, that's fantastic. Okay, so this is going to be 2,000, 4,000, so 2,000 pi. All right, and then we've got 2,400 pi all together. I'm just going to put that into my calculator. All right, so what I want you to get into the habit of when you write your answers, I was about to write a 4 and realize it was a 5. Write your numbers to quite a few decimal places. It's a good habit to get into. You probably don't need to do that many, but if you go on to do VCE maths, you need to show your answer before rounding. Okay, so for this one, we had to round it to 2 decimal places. So what I do is I cut it at 2 decimal places and then I look at this number here. So if this number is less than 5, I just leave it. If it is 5 or more, I round the 2 up to 3. So our final answer is 7,539.82 centimeters squared. All right, let's look at our next question. So a log with diameter 60 centimeters. So again, it's referring to the diameter. So remember, it's probably a good idea to then just write radius is 30, is 3 meters in length. So again, using different units. So we've got centimeters and meters. So there would have to be a conversion there. Its hollow center is 20 centimeters in diameter. So there it is there. Find the surface area of the log in centimeters squared, including the ends and the inside, correct to 1 decimal place. Okay, so we've got this whole outside area. We've got the 2 ends that kind of look like donuts, and then we've got the area inside. So just pretend if we were to dip that in paint, we're talking about every area that is going to be covered in paint. All right, so let's go down here. I might actually delete what I've just done. I wonder if I can quickly delete. All right, so I'm going to just redraw the diagram because I sometimes think it's a good laugh, you know, me trying to draw these diagrams. So there's our donut ends. I love pink donuts, by the way. It's kind of reminded me of a pink donut. All right, so there we go. And then the inside bit. All right, so you can kind of see its center. Now, let's have a look at our separate shapes. So we've got our 2 ends. Okay, so we've got 2 of them. We've got the larger cylinder. I didn't do that too well. Sorry. Should have done my little, it's always best to do these little things first. Okay, there we go. And then the smaller cylinder on the inside. So if we write the area for all of them, so this area we're going to have the larger circle, which is pi r squared, minus the smaller circle, which is also pi r squared, but your value of r is different, so just keep that in mind. The larger circle has a radius, what did we say it was, 30. So remember the diameter was 60, but the radius is 30, so we're going to write 30 squared. And the radius of the smaller circle is 10. Okay, so the diameter was 20, but the radius is half that, so it's going to be 10. All right, I'm just going to leave that as it is for now. The area just for the cylinder, not the ends. So the formula is 2 pi RH. Now, if you're ever wondering where that formula comes from, the 2 pi r is just your circumference, and then it's multiplied by the length or the height in this case. So our radius is 30. And then the height, what was it? 3 meters. So remember, we need to convert that into centimeters. So it's 300. And then our last one, same formula, but different radius. So it's 2 pi times 10, and your height is the same, or your length of the log is the same. Now, as I was doing that, I just realized we had the two ends. So just going to put brackets around there. So we have to multiply that by 2. Okay, so I didn't do that there. All right, so your total surface area, we're just going to add everything together. So we've got 2 times this, so our 2 donut ends. And I use brackets because it's 2 times the whole thing. Then we add this cylinder, so 2 pi times 30 times 300. Now you would have noticed I didn't put a multiply sign in there, but that's just because I'm used to not writing multiply signs, so I'm sorry, but it's an implied multiply. And there's the end. So quite a few things to put in. Now I'm not going to simplify that because it's going to take forever. But you should be able to simplify that if you had to. You probably don't need to do that in year 9, but as you move into VCE, they might not give you the final answer. They might give you an equivalent answer, and you have to see which one it is if it was a multiple choice one. So not putting your final answer in, but being able to simplify this. All right, so I'm just going to put all that into my calculator. All right, so our final answer is 80424. Now remember, write your decimal places. Okay, so they would keep going. Now the answer is, the question is asking for 1 decimal place. So I cut it off here and I look at the number after that cutoff point. Now, because that number is bigger than 5, I'm going to have to round up. So it's going to become 80424.8, and we're in centimeters squared. Okay, let's move on to the next one. All right, question 9. A cylindrical roller is used to press crushed rock in preparation for a tennis court. So if you play tennis, or if you watch tennis, or you've even looked at a tennis court, you'll probably notice the red dirt, which is called ontica. You can use these roller things usually to crush them, so you know the surface is flat. So this diagram here, it's a bit weird, but this is the roller, and this square thing coming out is your handle. So it's not actually a flat thing, a flat surface. It's just a handle. It's just a very poor drawing. Not that I can do any better. Okay, so the rectangular tennis court area is 30 meters long and 15 meters wide. The roller has a width of 1 meter and a diameter of 60 centimeters. So you can see that on the diagram. Find the surface area of the curved part of the roller in centimeters squared, correct to 3 decimal places. So that's just wanting the surface area of the outside of this barrel or roller. Then we have to find the area in meters squared to 2 decimal places of crushed rock that can be pressed after 1 revolution, 20 revolutions. So a revolution is just for the roller to go around one full time, so 360 degrees. Find the minimum number of complete revolutions required to press the entire tennis court area. All right, just as I was reading this second question, the first question, your answer is in centimeters squared. Question B, we're working in meters squared. So there's going to have to be some sort of conversion. So if you're working, if your answer has to be in centimeters squared, it's best to do your conversion at the start. Okay, and also meters squared, best to do your conversion at the start. All right, let's go ahead and start question 9. So a few parts for question 9. I was going to say I'm not going to draw a diagram, but I am. So the first one, we just have to find the surface area of the barrel or the roller. Okay, so the area formula, we just want 2 pi r h. Now I'm just double checking that it's not asking for the 2 ends. It did say for just the curved area, so we're just using that. We don't have to add on the 2 ends. And the roller has a width of 1 meter, which is 100 centimeters. Notice how it doesn't always use height, so it's calling it width. It's the same thing. Whatever the length is, the height is, the width is, and then your diameter. So we're going to convert that to a radius. Says 60 centimeters, so it's going to be 30. Okay, so just plug those values into your formula. So your radius is 30, your height is 100. So I'm just going to quickly do that on my calculator. Okay, so I've just deleted a whole bunch of stuff because I put it in my calculator incorrectly before. I actually multiplied it by 300. I think I was just had the previous question in my mind, but here we go. This is the right answer now. You probably weren't even aware I wrote down the wrong answer before. Okay, so that is to 3 decimal places. So cut it off at 3, which is here. And then we look at this number. So the 9 means we're going to be rounding up. So remember, don't round from your calculator, write it and then round. Okay, so we're in centimeters squared. Now for question B, we're looking at how many revolutions and your answer has to be in meters squared. So basically it's your same answer. We're just doing a conversion now. So we have to go from centimeters squared to meters squared. Now when we go from centimeters to meters, we're dividing. There are 100 centimeters in a meter. And because we're working with area, we have to square that. So you can put this in your calculator and divide by 100, but basically this decimal place is just going to be moving 4 spots because we're dividing by 100 squared, which is 10,000. Just trying to think, visualize the number in my head. So we're going to end up with 1.88, and you can think, all right, I'm just doing my rounding from here. It's to 2 decimal places. So this 4 doesn't mean we round up. So we're just going to leave it as 1.88 meters squared. All right, question C. Oh, sorry, that was just one part of part B. So that was 1 revolution. So we're talking about the roller going around once. So that was once. If we're doing it 20 revolutions, we're just going to multiply that by 20. Now, the thing is, if we multiply that by 20, we're going to get a different answer to if we multiply the more decimal places by 20. So I'm going to do both just to show you there's going to be quite a difference in answers. Okay, so that's 37.6. If we didn't do the rounding, okay, so if I didn't multiply that, I did the initial answer, so my centimeters squared from question A, so the 18,000, so I might actually do it over here. So if we multiply that by 20 and then did our conversion, so I'm going to have 37,691.11. So then we did our conversion, so I'm going to move my decimal place 4 spots. So that is in centimeters squared, and this is in meters squared. So see how there's 1 decimal place difference, and I'm actually curious to see what the textbook says, because either way, it just depends on where your, sorry, I should put the 0 there. So there's 2 decimal places. It all depends on where your rounding occurs. So the answers in the textbook is this, and I would agree with that because you rounded here, and then if you use that answer, you get 37.6. But if you use your answer from question A and then did your rounding, you get a more accurate answer. So you can see there's actually a 1/10 difference. Okay, let's move on to question C. So question C, find the minimum number of complete revolutions required to press the entire tennis court area. So the tennis court is there. It gave us the dimensions. It's 30 meters by 15. And just think, when you're rolling the court, you go up, back. Usually you just do half a court, but this time we're going to go all the way. Okay, just pretend the net's not there. So let's find the entire area. I've got so much working out on this page, which is nice. I always like to see when you girls have working out. Sometimes when you give me just your answer, I'm like, oh my gosh, it's like drawing a painting, or painting a painting, and just, you know, showing the finished product and not, you know, the process of it and the journey. It's much nicer to see all your working out, girls. So please make sure you do show your working out all the time. All right, so we've got 450. I'm just trying to think about how we're going to do this. So find the minimum number of complete revolutions required. So I would think you'd go up and think about how many revolutions that would be, and then multiply that. Sorry, I'm just thinking as we go. Our roller is only 1 meter wide, so we're going, well, that's not going to be 15 times, but we're going to go up and back, or up one length of the tennis court 15 times. Okay, so 1 revolution is 1.88. So we've got 30 meters. We're going to divide that by 1.88 to see how many revolutions we need to go up. 1.88. So 15.957. So just under 16 revolutions to do 1 length of the court, and we've got to do that 15 times. So we're going to do 15 times 15.957. And what is it to the nearest whole number? Or complete revolutions. So your answer, you do get 239.36, blah, blah, blah. So I'm just going to round that up to 240 because it says how many complete revolutions. So we're going to have to do 240. All right, ladies, keep going. You're doing a great job. Bye. All right, I just quickly looked at the answers for this question. It's 239. Now, I'm not sure if it was because of this rounding, because I used the 1.88 instead of the answer from question A. But I don't think that would make much difference. I won't bother doing it right now. But let's say my working is correct and you get 0.36. If we stopped at 239, we wouldn't have done the full chord. So I'm going to stick with my answer of 240, but maybe if you use the answer from A, you may get under 239, which would make 239 the answer. Okay, bye.